Yeah. As you know, today is our last lecture for this subject. This is actually santai-santai je. It's more, it's not so much detail on the what they call this. The steel is more like working on some of this innovative design by using steel. You know, the steel very rigid in form and very hard, rigid. But here you can see some of the example where the engineers and architects, especially, they try to create something which is beyond the capability of the conventional using steel structure for that matter. You can see some few examples, local and as well as local and non-local, maybe one or two overseas indeed. How this steel can create some very amazing form, especially curvilinear form. So today's basically is about innovative design, sustainability. So I've just touched a bit on sustainability. The first several slides, we'll be looking at sustainability afterward. Okay, that was the last one. Today, just I think about several slides slide on sustainability, just to tell you that how that's important, how is steel can be reused for many times. It never degrade their quality. If you look at here, steel is accessible material. Basically, it is can be cycled infinitely without losing its properties or performance. This is called multi-cycling. It can be cycled many times without losing its performance. It's unique among construction material. Research shows that 99% of steel rising from demolition site in UK is reused or recycled. So it's a fast, safe construction material. Kalau in UK tu, I stayed in Sheffield, I got steel mill banyak kilang angkatan besi. The steel mill factory around my area. Sheffield tu macam dia a bit very old town, tapi you know a lot of history about steel. About steel being developed by steel in Sheffield as construction material. Okay, how sustainable is steel? So basically, steel is very sustainable because once it's made, it can be used forever. Forever. Steel can be recycled on infinite amount of time and be used with no downgrading quality. I just mentioned earlier on. The renewable, non-renewable sources used to make steel, like mineral and fossil fuel, are not wasted because the steel will be used forever. These are some of the steel structure you can see, like Eiffel Tower. It was how many years back? 100 years. It still stands strong. But more maintenance. And of course, the weathering is not a factor that may deteriorate the so-called use of steel. We saw last week on how steel can actually fail if it's not properly maintained. So forever is one thing, but again, maintenance is not a factor to keep the steel if you want to last it forever. So what is recycling? I think you heard a lot of recycling kan. Back in the 90s, Malaysian government start to promote recycling of materials, but not so much effective because social culture of the Malaysian people too have not been, shall I say, sensitive so much about recycling, especially the city people. It's not too bad yet, but back in the outskirts, the small towns, so recycling material macam not so much a concern. But here talking, kalau you go overseas, anywhere you go, I've been to China, a lot of places, there's always this container or the waste, shall I say, container to where you separate the paper, plastic, and metals, whatnot, everywhere. So it seems that they are very concerned about recycling, so that it is not to be less. It does mean reuse. So you try to reduce the so-called carbon content in the air. This is also talking about the environmental impact of recycling. Basically, recycling is process of converting waste material into new material as object. Because we got machinery nowadays, we got the technology to do it. So that's recycling become, in fact, industry. Because small town, there's always a recycling shop, taking whatever things that you want to sell to them. I remember when I moved my office last time, I brought about 2-3 lorries of recycling material, including papers, metals and whatnot. Even aircon punya ducting pun is a lot. So they really take they buy your product. Okay, so recovering energy from waste material is included in this concept. Ini kalau cyclable, we can create energy. Cyclability of material depends on ability to require the properties they had in original state. So this alternative combustion waste disposal can save material and help lower greenhouse emission effect. That's why I mentioned about carbon emission. So it can also prevent the waste of potential useful material and reduce the consumption of fresh raw material. So we use less raw material, we use recycled material. Same quality as steel is the same quality as mentioned earlier. Reducing the energy and use energy air pollution and whatnot. That is a chain effect of cycling. It also contribute to keeping the good environment. All right, next one. Saya Alan, yeah. Oh, because I didn't show slideshow this right there. Okay. Basically, this is there are a lot of these kind of images or diagrammatic form of cycling material. In this case, for steel, and basically even you start from where? Start from we look at the center, the recovery of steel, production of steel, utilization of steel. So from 6 months, 1 year, all these script, they show you some of these materials, scale, speed, and all things. And then 50 years, maybe this is 5 to 50 years, even the sewing machine, what does it do? The other one is about to dryer, yeah. And then for cars, about 15 years it take to recycle. Tapi kalau dekat Singapore, after how many years you got to send for recycle. Dekat Malaysia, dia pakai sampai, they use until it really rot. Even in UK, for that matter, you can use it until the car cannot move. Well, you got to send for MOT. MOT means Ministry of Transport kind of check. So some nations, so they buy very cheap car. They use it, and sometimes it's not safe to be on the road. I remember I bought a car in the UK. It's only 2,500 ringgit, Malaysian ringgit. UK, I used it for 1.5 years. And that car, it cost me only £500. I toured Europe, 8 countries using that car. Still last. Okay, so crane kind of thing, 10 years, it will last 10 years, 500 for this pylon. Pylon is the electrical transmission cable stand. And then all manufacturing construction industries in all this kind of thing. So there's so many whatever thing that comprises of steel as a material, all can be recycled. Even plastic material for that matter, except for glass. Glass cannot be recycled. Glass somehow or other is they won't take glass for that matter. I don't know what to do with glass. So of course there's a lot of process of cycling. We will go shortly after on the kind of process, just briefly on the various stages of doing cycling work. This one you can find in internet banyak, a lot of these similar images from improved statement qualities, steel cycling society, application product, new forming process, new metallurgical technologies. Again, mention about technologies. There's so many new technologies to cut short or to save environment. Talking about cycling material. This is Australian experience. You look at steel is only 1% in Australia, but the rest like paper, glass. I don't know what glass in Malaysia you don't take it for recycling, but here you got 30% of glass cycling. Aluminium only 1% contamination. This is the result of this cycling material. This is Australian experience. Even talking about in Europe, a country the most cycling rate, basically they are in Germany. They are a very high technology country, advanced in terms of technology. They are probably the highest. They are so sensitive about cycling. Said maybe they are the highest compared to even Canada for that matter. The Hungary is the lowest. Canada is not. It's not Europe. And this is basically is all over the world. Some selected countries like Australia is about 41%. We don't have Malaysia. I couldn't find Malaysia. I was looking for Malaysia. I couldn't find one. But there is a kind of rate they're doing. This is in 2 years ago. Even global market for the country, they create a lot of money for this one. This is a business. I mean, it's now cycling is a real business. From 2013, generated about 21 billion worth of money talking about cycling material. And then it's expected by 2004 probably more than 135 billion kind of industry. So it is quite a big industry, so that people can survive with this kind of industry, cycling material. Okay, this is a process of cycling. Just briefly, basically, there are few, several stages of metal cycling. Firstly, they're talking about collection. Just when you sell the cycling material to the shop, scrap shop, they call it collection. So the collection, the shop will send to another collection center. Okay, the process will differ from that of the material because the higher scrap value. So steel, of course, it has higher scrap value. Higher, whatever metal product that you bring to the shop in the collection center, they pay you high compared to paper, compared to plastic, compared to other kind of materials. And then as such that it is more likely to be sold to scrap yard than to the landfill. Landfill, those domestic rubbish, kitchen rubbish, kitchen waste kind of thing, they send to landfill. But in case of steel, they send it to the collection center. Largest source of scrap ferrous metal in US is from scrap vehicles. I don't know what's number 6. Vehicle in US, they crush the vehicle, they send for scrap. So that is the largest scrap ferrous material. And then other sources include large steel structures, railroad tracks, or the railroad you can say, because the ships probably dissect or cut in pieces of the ship parts, farm equipment, and of course consumer scrap, from scrap which is created in the course of new product manufacturing count half the first scrap material. So when you see the image of this computer part, it's not so much steel, but there are also plastic material there. The next stage probably is you're talking about sorting. Of course, there are different kind of material. If you remember in the earlier lecture, talking about produce steel, you got to sort out. Sorting involves separating of metal from mixed scrap metal stream or the mixed material waste stream. Actually, that waste cannot be used and throw away. In automated recycling operation, magnet and sensor are used to aid in metal separation. Okay, you use magnet to actually attract steel for the metal. And then tapi alloy they cannot use magnet because it doesn't affect into magnet pool. There's no magnet pool. At the entrepreneur level, scrap may employ a magnet as well as observe the material color and weight to help determine the metal type. For example, aluminum will be silver. Yeah, people can actually distinguish aluminum as a material. Even aluminum and silver, stainless steel, there's a difference. You're talking about weight. Aluminum is very much lighter than stainless steel, right? Other important colors to look for: copper. Yes, copper you can see by color. Yellow for brass, red for brass. Scraper will improve the value of the material by segregating clean material, clean metal from dirty material. So the scrapyard is sorting center. Of course, processing basically, one they have separate, sort out all those material. They allow further process. Basically, its metal have to be shredded to small pieces, and then promote the melting process as a small shredded metal have a large surface to volume ratio. Basically, of course, all those big material you got to cut the small pieces, so that can be easily placed in the process line. As that, it can be melted using comparatively less energy. It's the bigger the pieces, the more energy is required to actually melt them. They can also be melted using comparatively less energy. Normally, aluminum is converted into small sheet and steel changed to steel block. This is the end product process. Melting, of course, we learned before about steel production, producing steel. So it's melted in large furnace. Each metal is taken to a specific furnace designed to melt that particular metal. Considerable amount of energy is used in this step. Steel, as mentioned above, the energy required to melt and recycle metal is much less than the energy that is needed to produce metal using virgin raw material that we use in our earlier lecture. From raw material, and then you turn into steel. This is scrap, probably is less energy because I guess broken small pieces, and then it's probably a metal product. They probably use less energy. Based on the size of the furnace, the degree of the heat and furnace and volume of metal, melting can take from just few minutes to hours, or a few minutes to hours, because of the small size of the product. So of course you have to purify it. Purification, the fifth stage, is done to ensure final product is high quality and free contamination. So one of the most common method is electrolysis, separate all this contamination from the product of steel metal. And the second last process is talking about purification, the purified metal are carried to the conveyor belt to cool and solidify the material. Solidify, we can purify solid, make it solid, turn it to what they call this block, and then conveyor belt to cool and solidify the metal. So in this stage, scrap metal are formed into specific shape, such as bars that can be easily used for production of various products. So this is the raw shape of the end product of the scrape, right? It become a C product. Then when you, so probably for another factory, we remold it into something, whatever product they wanted to do there. So lastly, of course, you got transport. Once the metal are cool and solidified, they are ready for use. They can be transported to various factories where they are used as raw material for production of brand new product. So when a product made of these metal bars comes to the end of the use of life, metal cycle process cycle again. So the beauty of this because it can be recycled many times. That's why that still, talking about industry, steel industry, it's a big industry. In India, among the richest uh, businessmen is all dealing. They have their own steel factories, industry. Even in UK, for that matter, there's one. I think from India. I can't remember his name. It's also because he own a steel factory, so he's one of the billionaire in UK. So I think this is about just touch and go on the what they call this sustainability of the steel. As you just give a bit of information that steel can be used many times. That's one fact that you have to remember. And also talking about steel can be you can sell it quite a high price. You sell it to a scrapyard. So any steel that you found, maybe somebody demolished or what kind of building, you can actually collect the steel and sell it. It can be quite expensive actually. All right. Now we go a bit on the second aspect of it is on the uh, innovative design using steel structure. As I mentioned on introductions now that
Slide berapa tadi? Kita orang dari college tadi.
Oh, itu college. Oh, bukan sini.
Bukan?
Itu dengar tadi, dengar kan? Ya, tengok.
Dengar,
Kat mana?
dengar.
Kat mana dia? Oh, dengar. Tadi slide tak dapat. Aku ya dah buat dengan kau ni.
Tadi slide dapat pasal dia terputus. Kita keluar terus.
Terkeluar sampai kat mana je?
Sampai yang tadi tu.
Itu kosong.
Tadi yang 26 yang silinder. Silinder 26.
Oh ni Gherkin ni. Yang ni.
Benar.
Oh ya.
Ini.
Okey, dapat tengok semua? Can you see the slide?
Belum Haji.
Belum? Belum.
Belum.
Alamak. Cuba dapat.
Haji soalan Haji dah terkeluar, mungkin Haji kena share balik.
Share balik kau.
Haji
Okey.
share screen.
Kau mana kena buang kau ni kau ni? Besar pula. Saya kena buang ni. Pusing tak nak pusing.
Cuba Haji tekan more tu ada dapat. Dekat more.
Mana?
Okey, situ.
Oh. Baik, saat dia aku buat dia keluar je. Keluar. As if full screen ni.
Mana sharing kan?
Baik. Try kat di satu-satunya.
Haji tekan bawah ni, Haji close dulu participant.
Mana?
Ini yang ada arrow bawah ni.
Oh, okey.
Haji close.
Oh, aku tak jumpa.
Tu. Share screen.
Okey.
Tu share screen. Baru ada.
Aduh, betul lah. Dia tak rekod ya, rekod tak ada.
Ada kata tapi Haji tak angkat.
Aku tak angkat, aku silent kot. Tadi aku solat tadi. Betul lah, aku dah agak apa. Okey, nampak tak?
Nampak.
Sharing.
Nampak? Ada, inilah teknologi namanya. Sorry guys. Tak apa, kita pernah sambung ni Okey, terima kasih banyak. Okey, Abang. Sekarang tahu you call saya. Daripada college, kau terbang kan? Okey, tadi ada rakan you datang lagi ya. Lupa tak nama tadi. Okay, I'm sorry for that. We were here before kan. Yang ni just to show you the so-called use of structural steel in a building that has been designed with some there's some similarity on the form. I don't say symmetrical because it's a circular in form kan. So it's a more repetitious kind of structure lah. But again, it tapered to the top from bawah tu like it's a bit narrow, then it goes up, bulging a bit, then it goes tapered to the top. This is by normal structure. There's a lot of creation, a lot of innovation here, where there's some control of air control in the area in the center using this kind of Trusses structure. I mean, you can study lah on in this entity. There are a lot in the internet about this building. You see, I was talking about again. Talking about the stiffness of the steel when the building can be shaped in such a way that the form looks very soft, curvilinear, and really fluid, fluidity, and just by using steel. Of computer software, it's not so much detail, because the Fangari they produced the so-called by the aid of computer three-dimensional interactive application. They call it Satya. Satya basically used for aviation, for designing of aircraft, and also automobile industries to create the form of aircraft and transportation. Satya basically have to define the complicated 3D curve surface using several polynomial equation based on numerical control, give accurate position information even of specific point of a curve area. What we're talking here is that you have a curve surface, every part of the curve too, there is a point that you can determine so that it can design to make this two kind of curve, especially found in the industry, in the aviation industry, aircraft industry, and also automobile. So they employ this for the building, so that every part of the curve too, there's a point that it can be bent, can be turned, so that the so-called the manufacturer aspect of the design, they can put in the computer, then they can curve by actually using this kind of software. So they define CAD and KM, computer aided manufacturing, computer aided design. Macam sekarang ni pakai computer design, dia ada satu lagi dia call computer manufacturing. They use software, they put in the material at his own at the space and the place in the factory, and then they can curve it according to whatever surface you want to create. And then on top of this, Satya software has led to innovation of many software such as Grasshopper, Karamba 3D. So these software are the modern tools for shaping the steel material structure that are functional and practical to be constructed at the site. This is basically extract from my student thesis, topical study on curvilinear form using steel in curvilinear form. Dia nama dia Maharani. Maharani baru graduate last year. I'm her supervisor, so we were looking at all these kind of how they manage to do it in a way. So there are a lot of this new software that they have created to actually make this kind of building possible. Okay. It's similar thing. You're talking about Satya software. All the curvilinear form here, they can detect even all the composite panel as a finished material here. They can detect. Each piece has its own code. Just imagine there are thousands of it. They got different code. They have to fix together at a particular point. So only software that can actually detect the curvilinear form. When they combine, it becomes very smooth and very, very what's called this aerodynamic kind of form. It looks very fluid, and again, there's some form of like some kind of movement to it, and very, shall I say, it's alien to this place. You look at those buildings behind, a very rigid kind of block of apartment. Compared to this, it's like jewels to the city of Azerbaijan. I think this one. I was actually asking myself when I saw this building, I was asking myself to what kind of structure they're using for this kind of building. So I was trying to guess myself, probably they use steel tube. I was thinking they use steel tube. Tube, it can be bent, they can follow the line. But sure, I was wrong. When I saw the structure drawing, they use space frame. Even space frame for that matter, they have to create such a way that the frame can be bent also. The part of the frame can be bent in such a way that to create that kind of smooth surface on the top. So these are all again with the computer can do this. If not, I think it's a bit difficult to do conventionally, of course. Like the stadium Shah Alam yang deteriorating sekarang tu, sama lah same case, tapi dia very simple curve. Just satu, symmetrical kind of curve. So that doesn't have that kind of challenge so much. In this case, the challenges is this but the fact the internal structure for this one is only concrete, post and beam, concrete column, post and beam. But the wrapping of the skin that wrap the building is they use this kind of space frame structure. Maybe there are more features in it. Look at all these members to design such a way that it's being calculated, whatever formula they use being calculated to create the bending. I look at my mouse. See the kind of bending. All the members have different code, and then they join together, create such a very smooth bend. But looking at the so-called the nature of space frame, it is very rigid, triangulated kind of form, very rigid form. But again, the finishes outside they can create such a way that become very smooth. I said innovation in steel engineering, which I think not many willing to take the challenges. Of course, Zahadi being the designer of the architect for this project, she got her own way of doing things. She has full confidence that industry can do it. She has confidence that all the technology can do it. So she tried her best and end up in some very interesting building, very interesting building. This is even the cladding as mentioned to you just now. All the external cladding have been being formulated in such a way that they fit at their own place. They fit at their own place. They know they cannot miss it. Or they miss it, got to produce another one. No other, probably not many are of the same surface. Covering surface. Not all the pieces of cladding here is on of the same design. Mungkin kat sini sama lah kot, tapi yang mana yang kat curve macam tu is of course different kind of design. Okay, this touch a bit on that, the complexity of the designing this by having to use the space frame structure. Okay, come a little bit local. This is very small, but again talking about the innovation in creating a curvilinear form by using this space frame. This is local. This is somewhere in PJ. I think now has been removed. It's only a showroom of this PJ City Center designed by Hijaz Kasturi. Hijaz Kasturi, you all know, kan? He's quite a famous Malaysian architect. Even he was born in Singapore, he was bred here. He started his career. He's among the earliest architect that I know of. He was once my head of school in ITM back in 1967 or second. I wasn't there yet. I was there in ITM, UITM 1972. So he was the head of school then. So it is a very simple structure, overlapping of pieces of, you got, spring roll, and then you cut and you slice it, and then you move the form to become like this in this kind of form. This is plan, but this plan is not very clear anyway. I just have to show the structure and the form. This is how they design, like you see every part of the design is different sizes because of the curvilinear form. Every part is designed. This is different. It gets bigger, then gets smaller, and goes up again. Probably this might be the same. This one again, it goes down again. So every piece of the slices, I call it the slice piece, is different in size, and you can see that it's different. And you cut every section will be different. But the standard formation of the steel structure is the same. The core, the curvilinear form, the standard facing for the roof, the batten, the purlin for the roof is all the same. This is some of the structural features created. This is what I mentioned to you just now. This is a tube structure. For curvilinear, you can use tube structure. So I thought that the Hardy project was something like this, but it's not. They use space frame structure. Some of the details. Very simple. There's no internal frame, no internal support. Just support by its own weight. By having that curvilinear form, it supports by its own weight. The footing is right here. You see the sketch here. The footing is there. Okay. And this is some of the material, aluminum composite panel for the external roofing sheet. And then steel stud, they got it. They got stud. Stud means the main frame lah. Kita ada stud and so lagi nogging, nogging the vertical lah. Tapi that one for wall, but this is part. We can say wall and roof is the same. Steel stud plus the board is the internal use, interior material. Tubular steel bracing, the switch is bracing to make sure that it's not avoid swaying. You got insulation, of course, fiberglass insulation. And then main tubular steel frame. This is the big one that goes vertically. And this is very, very simple kind of construction, column-free construction. And they create lighting where the split is, then there will be some indirect lighting coming from here. Look at the roof here. So the interior can be very bright, without having to have more light bulbs, electrical bulbs, artificial lighting. Okay. This is the form. They call it the curvy form of the pot. They call it pot. The same as a pot, POD. is divided into different segments. As you slice the segment. Each segment that come into different sizes and height from 4 to 8 meters. Okay, it varies. Vertically also varies, horizontally also varies. And then in order to achieve the curvature of the form, each segment is constructed with main tubular steel component that are coated externally. Okay. Then these components within hollow section are bent according to different angles and radius replicated by manufacturer and maneuvered to the side. So these tubular steel components for each segment are connected with steel stud to produce a collinear segment. So this segment are arranged in rhythm, it become rhythmic form, according to the plan to get the movement of the form and connected to the reinforced concrete foundation, solid foundation. So this is designed by. You know where you get this idea? Oh, in fact, I just from apa ulat punya ulat from ulat. What they call the English ulat? I couldn't recall it. Computers. From kampung become ulat.
Caterpillar.
Yeah. Bila tak dengar. Yeah, ulat. Ada foto, but I think I teromit juga. I got one photo, but I simply omitted that photo. Complete foundation. Okay. Okay. Now is the main focus for this. Let's say basically, I want to show you. How steel structure can again create some curvilinear also, but not so curvilinear as RDF Museum just now. This is designed by RSP Architect, local, based in KL. RSP is very big company, just like GDP also. They're one of the biggest company in Malaysia. They're based in Singapore. They formed branch here, but now the branch owned by Malaysian. One of the partners is my friend. So they are doing currently the 118 tower. They are the local architect. Combined with the engineer, what they call this international architect. So this is MITEC, Malaysian International Trade Center. Malaysian International Trade and Exhibition Center by SB Architect. Basically, if you know where is Masjid Wilayah is, that is just in front of Masjid Wilayah, not very far from Masjid Wilayah in KL, somewhere Jalan Duta there. So this second organic building design that gone through visual observation was Malaysian. Ini buat daripada Maharani ni, Aztec ada Aztec benda dia punya ni. Design by SPR kita, the building situated jalan at number 8 Jalan Utamas, Komplek Kerajaan dia, ni kerajaan wilayah persekutuan. It covers an area of 141,000 meters square. That's quite big. You kali 10 lah, nak tahu square feet. With inclusive of car park. The building was completed in December 2006. Now it's open. They got this idea from this rubber sheet. That's why you see the shape is a bit. This is something, just ideation, not so much the concept of ideation. And of course, they were trying to create something unconventional for a conference center, by having some, again, the wrapping up the roof, by having some pattern that probably echoing the rubber sheet form and pattern. Kadang the form look a bit weird, macam just a soft cloth that you wrap something, but it's not completing wrap. It's like a short of some of the building is being exposed. You were trying to push and wrap something, to cover everything, but not enough clothes for that matter. All right, this is the building form. I will show you the detail until you see how they construct this one. This is the initial sort of development from the architect. The architect is very helpful. They give a lot of this their drawing. After my intervention, like not they won't give. I said they are my friend, my son director. I said, okay. So this is initial sketches lah. Services, exhibition hall, concourse. From the rubber sheet atas tu, they break into various form there. design strategies in a way kan you learn about design strategies kan in your previous project tu. These again some of the earlier sketches and generation from the cat drawing or from rabbit maybe. They created a model. Once they finalized, they created the models. I mean, to some client, they may not be. Your convention is something that you can express the form. So that most of these museum, convention center, art gallery, most architecture they can express architecturally and also in structurally. So this is how the design look like in elevation. Quite a massive design. 141 meters square is very massive. Probably about 8 or 9 floors. This is another view from the side. They got level 1, 2, 3. That is about the highest is 36 meters. 36 meters already exceed the 18.5 meters, which is fire requirement. It has to be very active requirement. Kalau for high rise, they call it high rise after 18.5 meters. About apartment more than 6 story is already considered high rise. In this case, look at the floor level, it's very high. Third level, probably the convention center, like 13 to 36 meters high, it's very high. This is the kind of distribution of space and loading platform, loading, unloading at the back here, back of the house, and then the exhibition hall, the convention center in the middle, and then of course the rightmost is the concourse or the public area, the lobby. 3 main structure level, mezzanine, and 1 substructure level. I thought they had parking basement, just one both side basement parking there, and then the different height given to you. And this is another longitudinal section. And this one we call cross section. This one we call it longitudinal section. You can see the height there and the form of the roof. This is the component method of the roofing system. Some of the material being identified earlier on, like low E glass, concourse, expanded metal screen, and then the southwest view, some S column. I show you some S column in detail. Quite a lot of photograph on S column using a steel tube to create the column. Even C column for that matter, S column. This whole roof system is a S column and C column. Because roof part of the roof is joined to the wall and become it meet a foundation as the support system. This is some of the detail of the so-called finishes that wrapping steel frame that wrapping up the building. Look at the tubular form that give you the curvilinear form, and then the so-called nogging or the nogging also can, purlin also can. When it goes to the top, it become purlin. When it goes to the bottom, wall become nogging. It's the same thing. Again, I was mentioning about tubular. You can use tubular form. It is very easy to actually create compared to the so-called curvilinear. The space frame, because just now you alleviate a museum there because the opening space is huge. I mean the roof supporting in one of the large space without supporting like a big lobby. There's a huge space. Probably they cannot use this kind of frame. They got to use long span structure. So that we learned earlier on. Space frame is long span structure. In this case, the long span structure is at the hall. This is the finished product. There is the raw exposed material structure. And this is the part where the C column, the S column is there. This is the finished product. This is the S column. It's not that regular. You see the bottom column here, not regular. Okay, it was like very irregular kind of form. So not at a fixed center to center. This is the whole structure system. This one is software Midas Gen was used to analyze and design the roof steel structure. Design verification was done using alternative software, SAP. So there are a lot of this kind of software, the latest software that can actually help you to determine the kind of structure that fit the place. In this long span, right, from left to right is from X Y Y is all long span, okay, covering the holes. This is the one is by the side is like supporting structure. I can't remember what they call it, supporting structure. Okay. Is some data here to got total steel tonnage about 6,000 ton. Final cost of steel structure alone 47 million. Main roof 26 million. Roof level 1 70 million. Level 2 roof 2 is 3.5 million. Just the roof alone, they probably cost you almost 100 million. This is the S column. I mentioned this one, S column, as indicated by the dotted line here. They call it S column. This is not the S column at the back here. This is the whole plan view of the main trusses system. This is the MTRT main truss by numbering. Probably this is also number here. This number 12, 13, 14, 15, 16 by numbers. This one plan view. Method used for the main induction of fall system, fall work system, and 16 to 18. So there's some kind of system being employed to erect the trusses. Erection using lifting tower. I show you lifting tower 1 to 10. This is 1 to 10 here. From here 1 to 10, they got a lifting tower like not tower crane. They use jack to lift it. I show you that. This is some detail of the trusses. Top view of main truss. Inside view of the main truss. Like they combine these two, they pair up. This is span of 70 meters. This is another 50 meters there. This is the detail of the pair. It come in pair. This is like a pair of roof truss, the main roof truss. They give some detail on top chord, bottom chord, diagonal chord, vertical chord, bottom tension support, all the detail. And then the welding test was also conducted. Of course, for welding test, every part of the welding, there's some tests for actually big structural system like this. For normal welding, is no problem. This is the term that we study a lot on top chord, bottom chord, bottom tension rod. There's tension rod there, so that it can support the whole roof. We got a long span here, and it tapered by both sides. Vertical chord, diagonal chord. This is plan didn't show so much, but I just want to show the red point here. This is the main column. The red colored point here, or the main column. Quite big column. This is main roof support. This is what the AES is now. AESS, architectural design, the way that the support is a nice looking support, and not just engineering, but also architecturally nice looking support. Look at the frame here, is tapered to the bottom with some gusset plate, nicely probably welded and this bolted and joined from another frame for the roof. Detail of actual roof support. This is I think conceptual drawing. We don't have the mark here, fixing or RC installation anchor bolt. It's supposed to be number. I couldn't find a number except from this is some of the details. One of the details of the foundation. This is the base plate for the column for the roof. Look at the base plate. You got foundation. It's just a big foundation here. Main roof base plate. And then we will see after how the base plate look like. This is the base plate look in elevation. You see the reinforcement there on top of the piling. Then you got a plate. This is special design plate. I don't know why it looks so protruding kind of thing, like maybe you hadn't seen the finish yet. You see the finished product. This is the roof support. I mentioned support architectural AESS is now. Different size of tapered again. Special design kind of roof support. And these are all exposed kind of roof trusses. You can see the way it being joined. It's lifted up by a big crane, and some lifted by lifting up by the special support. One of the MTR13 segmental trusses was lifted by crane and placed on the horsework. This is the gantry that they lift up the number 1 to 10 of trusses. They lift up by the gantry. This temporary. After they open this, there's a jack. I think there's a lifter. This is a jack there to lift up all the trusses to its place, and then they fix on the column. This is column taking out the place. Circular column. Lifter MTR was done in pairs. I mentioned the pair come to pair together. There's a lifter jack here. There's a cable that lift up this frame. There's a cable here that lift up the whole of this big roof trusses. They don't fix it one by one, but now they put them in pair. They have to create this kind of temporary gantry to lift up the roof trusses. Even if talking about lifting by the crane, so it's not possible. It's a technique of construction. So the roof seems to be the main feature of the place because the nature, the size of the roof, and the complexity of the roof. The rest are all conventional. Talking about, constructing the floor slab. All these are conventional. So the roof is something the feature of the place, and again, it's quite intricate in terms of engineering. Design and aspect of fixing the roof, placing the roof at its own place. This is a kind of finishes. So it's on the roof. We show you the detailed finishes after. This is the side or the side structure. The main roof right in the middle here. The C column is there. The S column, another one there. This is the so-called column here is 1.5 meter diameter. It's quite large, this is about 5 feet diameter of column to support the roof. This parcel of the roof. Quite a bit. The red colored column I mentioned, I showed you just now, is comprised. It's made of 1.5 meter, in diameter, circular column. This is the assembly of the trusses, and they call it force form. This is the side one, the side. And this roof AES is detailed to be exposed here. So the detail can be expressed, can be seen externally. This is not the detailed roof, which same that we chose now. Okay, this is a column. This is the S column. Look at how we show you some of the detail how to actually fix a column to concrete. There's a bolt and nut there. And this column was specially designed because it's tilting. So all the frame around it also is tilted. 8 column base plate was placed on an anchor bolt, cast in the IC, the anchor bolt there. This is the S column that goes up to the top. It's all pre-cast, also prefabricated in the factory. They just bring in the segment and they fix at the side. This is the S column. Number 2. This is the one. So some of this has to be anchored to the wall to make it stay in its position. This is more of your S column. And this more these two photographs here on the S column. As being this is probably the top part coming up to the curvature of the roof with some bracing, horizontal bracing to make the S column stable in the position. This is rising up to the top. The column. This goes to the top. And it gets smaller, probably to match with the roof structure. Look at how they join from the big S column, and then they weathered another of the same diameter, then it's tapered to again fix to the roof, part of the roof trusses there. Can be done. This is all custom design, so it's a bit expensive to do this. This is a bit of a review of some of the building, part of the building. Again, it looks massive. So this internal view of the building, where this is a concourse. Concourse is the foyer, the lobby. This bow, they call it bow truss. Bow truss, you can see this KLIA airport. Bow truss is to take up the curtain wall. Curtain wall is a glass wall, glass wall that fixed to the bow truss. So glass wall can be heavy. This is the finishes. A bit of glass, concave glass wall, some little glass panels, all but glass there. There was a mesh screen, and then steel frame glass panel. Some the roof tak nampak sikit. Some more details. And then the roof detail, I showed roof detail. Roof material particularly aluminum folded aluminum panel roofing in diamond pattern. SK PVC membrane roof. There's one detail on roof as shown. This is more on the cladding study when they were doing a simulation maybe. Again, it's on the roof pattern. This is about the roof. So the roof pattern, they got to have this roof pattern of 200 mm and 50 mm gap. There's a gap in between. But this is not the finished product. I mean, this is another layer where to protect the water from penetrating. The entire roof is made of 20,700 pieces of ACP material, aluminum composite panel material. Diamond pattern size varies from one location to another due to the curvature of the roof. 50 mm to 200 mm gap is designed to achieve overall pattern concept. You got to have a gap, that concept here. This is how the roof being constructed. Tak pernah nampak, I cannot read this. I show another one. This is the material of the roof. You can see the deck below to support the insulation. This is a rock wool insulation. They call it like padding. It's not the small that come in roll. And then they got another fiber cement board on top of insulation. Then they got the waterproofing Sika Sanofi membrane below it, and then only they have a carbon SCP panel for the roof. So there are how many layers? 1, 2, 3, 4 layers. 5 including the membrane structure. So this detail of the roof seen at the side, but if you draw a section, you want to imagine how the section look like. Okay, guys, I think that is about all. Okay, a bit more on the bow truss. To take up the panel, the wall, the curtain volume of the glass. Okay, I think that's all. All right. So basically, to give you an idea for this particular lecture, other than accessibility of the material, basically, steel can be designed in whatever form you want, because currently we have the technology to actually create a building with against the conventional use of steel form. So don't worry about it. I mean, as far as the use of steel, it can be done. Concrete also can be done, but concrete has some disadvantage because you need to cast, you need to cure, dry, time consuming, and it has to be done at the site. But for steel, you can fabricate at the factory with all the work and the shop drawing given, and then just pick the site. But if steel structure, then when you get to cast at the site, then it's very difficult. The formwork has to be very, very perfect. If not, you will not be getting the kind of curvature you require. Can be done, but it's a bit difficult for steel. But I mean for concrete. But steel is no problem. Can do it. This is something that I thought that to give you a bit on this issue, so that you open up your eye that we can do construction of material by using steel. Okay, guys, any question? Nanti kita tengok sikit on your assignment, assignment 2, the final assignment. Ada question, guys?
Ada Haji.
Tak ada? I was looking at your your design yesterday when we were reviewing, tapi saya tak tahu, mungkin ada sebab-sebab kenapa you tak include steel structure dalam drawing you. Saya tak tahu sebab kenapa you all fail to include steel structure in your design of your Sarawak Children Museum gallery. Ada tak sebab? Kau ada lecturer tak setuju ke, tak bagi ke, ada tak? Bukan nampak macam pelik sikit. Anybody want to say anything? Ada tak? Kayum nak kata apa-apa tak? Kenapa you tak includekan steel structure dalam design project? Are you all there? Ada korang ni?
Ada Haji.
Ada. Agak kenapa? Kenapa you tak include Despite I remind banyak kali kan? I rasa banyak kali juga remind tu.
Maybe sebab kita orang refer.
Tak ada echo sikit, tak dengar clear.
Kita orang refer senior punya, waktu senior macam tak guna still, so kita orang ikut je.
You refer senior punya project? Tak boleh, senior project lain. Dia masa tu, they was not stress that they need you still, because kita dalam contact integration, nanti dia question, nanti lembaga arkitek pun question, nanti bila datang ketasi kan, you kata you teach them on steel, tapi in the design there's no steel structure at all, sure no, itu kita in trouble. In trouble, except for trusses, the rest column tak ada steel, beam tak ada steel. So I was shocked juga masa dia tengok, I memang terkejut betul lah, kata kenapa you refer the senior pula when you are actually dealing with me and studio master semua tu. Tu yang pelik sikit. You lebih prefer senior daripada kita orang. Ya, betul. Itu I was very shocked. Salah platform tu, you refer pada salah platform. Because I try to show as many details as possible kan, so that you can employ one of the detail and plug in or copy to your readjust your design tu. At least adalah something. Tapi macam ada sesuatu macam orang tak bagi buat ke, ataupun you macam kata refer kat orang lain tu, memang salah betul lah. Itu sikit, sedih sikit kat situ lah. I thought that bolehlah tengok some application of steel in your design, tapi tak ada. Takut mungkin ada lecturer tak bagi buat ke, terus suruh pakai concrete ke. Tapi nampak I fail in my lecture. For the past 14 years I fail in delivering the lecture to you. Mungkin delivery okay, tapi fail to probably advise you accordingly. Itu sikit lah, saya sedih sikit lah kat situ. I thought that the system that we ask you and then you apply je. I thought it was like that, tapi actually it doesn't work. Of course, most of your details more wrong. I see your detail, your description detail semua salah. Macam pelik sikit, kenapa tak dibetulkan. As a lecturer tak pandai study detail, atau lecturer tak pernah bekerja, lecturer pun tak tahu nak komen pasal detail. Saya tak blame you all juga. You all kan ada pre-submission, kan? Lecturer should be corrected all the detail, kena komen semua. Kalau tidak, nampak kalau kita nanti, kalau all the detail, saya tak sanggup tunjuk kalau kita see next semester, next year. Nanti all the panel tengok semua, dia tahu semua dah. Macam-macam condition presentasi kita. Itu sikit, saya rasa feel sikit. convince you. I wish that I can see all the detail, correct detail tu balik. Memang banyak tak sesuai betul lah. Tapi itulah. My real disappointment is because of this no incorporation of steel dalam building. Itu sikit my very disappointment. Okay guys, I hope you remember this. Next time kalau you listen your lecturer, don't listen to your senior. Thought that's supposed to be the rule. Unfortunately, it's not. Doesn't happen. So I pun kena pelik juga kita sounding kenapa ya. I was already wondering, I was thinking of myself, kenapa tak buat satu pun tak include. Padahal kan kita tunjukkan nak draw I-beam kat beam kan. Aku nak collect kan dengan box kan, nak concrete pun boleh. Apa nak I-beam atau H column ke, draw H column, contact column tu macam H column. Detail tu tunjuk sikit. Ni detail C. Brickwork okey lah, tak apa lah kan. Brickwork boleh pakai dengan C, tak masalah. But subtly it's not there. Okay, so your submission of ni supposed to be hari ni Task 1, task 2 tu.
Haji hari ni.
So I nampak pun satu ambil tu pun anda ni report je. Bila assignment you dah tak ada assignment lain tak? So sama tu banyak clash ke ataupun banyak nak buat ke? You have a lot to do.
Haji untuk assignment tu dah siap dah, cuma tinggal nak plot. Tapi tadi makmal tutup, soalnya kena print kat luar.
Okay. So I give you until tomorrow lah. Tomorrow, Friday, everybody must hantar assignment tu 1 and 2. And then assignment 3 tu, final assignment tu yang bagi tu, dia I tak ada pre-submission tau, betul-betul ramai sangat. Aku tak banyak sangat. Nanti I bagi some sample untuk buat portal frame. Itu mudah ya portal frame tu. Dia tak ada macam you buat rumah tadi kan. You buat rumah tu memang complicated sih pasal banyak ada bilik kan. Tapi you all tak, yang pelik you all tak baca brief betul-betul lah. Semua then you punya my comment tu pelik you all buat, mungkin you all tak sit together among your friend. So orang buat lain, ni buat lain kan. Rumah tu saya cakap not on steel, maksudnya on the ground. Ada juga tiang-tiangnya banyak, mereka semua ada tiang. Lepas tu ya detail pula duduk atas ground. Itu saya confused. Saya pada pening macam mana you all boleh buat macam tu kan. So looks like you all tak apa sensitive lah among yourself kan. You tak sit down together, coordinate balik kan. Macam work independently. Of course the punya nature of the ni ada concrete floor, ada concrete beam, ada kita kan steel kan. Pakai steel lah, jangan pakai concrete. Itu I rasa macam pelik, takkan you all tak faham kadang-kadang I was wondering juga message tak sampai ke ataupun you all ada lecture ke, tak ada ke. So through assignment kita tahu sama ada you really engrossed with the lecture, understand lecture ataupun tidak. Through assignment kita tahu sama ada you faham tidak, sebenarnya tak faham. So sampai next semester, next akan buat strategi lain tak. I ingat you all boleh faham lah, every time I tanya you faham kan, tapi dah tengok produk assignment tu actually tak faham langsung. It's I get disappointed situ. So I rasa macam tak efektif sangat lah rasanya. So never mind, the show has to go on. You submit nanti, and then kita ada satu lagi exercise. Tapi ini quiz lah, sikit lah quiz. Quiz tu I tinggal belakang sikit pasal kita last day submission of mark ni 21 kot. So lepas you submit tu kita ada quiz, tapi I akan hantar you, kita pilih beberapa topik saja. Kalau bagi semua topik tak mampu nak buat. I pilih hanya 3-4 topik je. Dan secara topik tu quiz dia objektif bukannya jawab ni pun ABC je, betul tidak itu je. Just fun aja. Maksudnya nak refresh balik sikit lah what we have gone through, but dari scope yang kecil, probably small scope, probably just 4 lectures saja. We consider 4 lectures saja. So kita ada lebih kurang 40 question. Each question carries half a mark. We got 20 mark for quiz. each question carries 20 mark, and then nanti I'll give you the section of topic tu. And then kita akan fix date lah ya, after you dah submit lah. Submit yang task 1, 2 ni mungkin in between from now to task final submission kita buat satu quiz. I give you few days to refer lah, to refer the notes kan, dekat Goal ada upload semua, except for this one belum lagi lah. Refer kat Goal nanti. Then I will WhatsApp you the topic that you need to study lah ya. Just to complete the process of marking system lah. Currently we have a quiz for 20 mark for the quiz. Okay, yang individual tu is another 40 mark. So individual tu kalau you okay, I just ask you, you understand the question on the final assignment? Final assignment 2 tu. Not task 2, final assignment, sorry. Faham tak? What is required? Hello, you all there? Aisyah faham? Hidayati faham? Balkis faham? Heba, you there, Heba?
Yes, sir.
Okay. Do you understand the scope as mentioned in the assignment, the final assignment?
For the final assignment?
Do you understand the requirement, submission requirement, and the assignment itself?
Yes.
Okay, understand. Okay, but I give some sample. You have to complete yourself. I'll send you through WhatsApp some sample you need to do. I mean, you can follow some similar sample. It's not that difficult as compared to the one you're doing now, yeah. Okay, guys. So I have to go now. I didn't get some good response from your failing to incorporate my steel. My steel, I call it my steel actually.
Content tanya boleh?
Boleh.
Okay, kalau untuk final project ni kan, maksudnya bukan based on design final tu lah kan?
Bukan. Final project ni portal frame. Portal frame tu yang simple portal frame, dia ada bagi size kan, give you the size. You draw the plan and draw the floor plan, draw the machine floor, and then you space out your column, you draw isometric kan. Itu je. And then of course section detail, some detail. Itu je, some description why you choose. Itu je. Individual. There's a portal frame very simple. If you see the what you call it, the video that I showed you, that portal frame that collapse, something like that. And if you type portal frame detail internet, that would surface. It give portal frame isometric view. There's a lot of that. And we got to include what the component of the portal frame. There is a bracing, the wall cladding, the roof, the cover roof, the trusses depend on you. Sometimes you can use just a simple arc trusses or just a simple I-beam for the trusses. It's up to you, your choice. But it's more simplified. I think it's 1 week more than enough to do this.
Specify all the should specify all the like components that use steel construction, right?
Yes. It's only the roof and wall component.
Only
roof and wall component. Yes, and of course the frame structure. What you have the component, the roof. You got purlin, you got insulation, and then you got the steel decking, those kind of things. The wall.
How about the base? I mean the foundation concrete.
The base is concrete floor. Sorry, the base is concrete floor. The portal frame sitting on concrete floor. Okay.
So we mentioned also about the base, foundation, or
foundation. You can include just pad footing. Okay, pad footing, spread footing. We show you last 2 lectures on footing. Just they call it spread or pad footing. A square concrete base and then you what they call this, raise up to the floor level. That's where you put all your column, steel column, and then join with three struts. So there's not much of a bottom chord there, because you have only, sometimes you can only just use one I-beam that is good enough for portal frame. That I-beam sometimes is tapered. Once you go to the middle, it get narrower. Then you go to the columns, it get thicker. There's a lot of example. Just type portal frame in the net, they give you a lot of example. Yeah, but I need to do it in isometric. Part of the building is full, show the wall and the roof. The other part is just skeletal. I think I show you example. Maybe you can copy example in your final design. Okay, guys. Ada lagi? Is there any more question?
Lagi. Yang assignment tu dengan rumah. Nanti portal frame tu dia tak ada tingkap atau pintu kan?
Ada kan, cakap ikut rumah tu mestilah tingkap pintu. Jangan buat macam store kan. Tapi your design, kalau for yang task tu rumah tu kan, your rumah tu, dia hanya tunjuk structural frame tau, ingat structural frame is not paneling apa, tak ada pun, just frame saja. Roof frame, column, roof beam dengan trusses, itu je. Structural frame. Kalau nak masuk dinding boleh, tapi jangan masuk semua lah, masuk buat detailing dinding boleh, tak apa. Because ada cross section kan, turun keluar dinding. Tapi kalau isometric tu frame saja, frame. Masuk yang lain tak apa. Because I just minta structural frame saja. How structure look like? Macam you bayangkan, it is like, you imagine it's like a post concrete beam and column. Macam tu lah, instead of concrete beam column, it is made of steel lah, itu je. Siapa ada bagi dimension kan, bagi alternatif, pakai hollow section ataupun pakai I-beam atau H-beam for column. I-beam for the beam, H is for the column. H-beam, simple sangat. Boleh Okay, so besok jangan lupa put in my room nanti. Okay, I think that's all for today kot kalau ada apa-apa salah silap saya, saya minta maaf banyak kadang-kadang saya pun banyak juga benda yang tak cukup ilmu saya bagi semua halal tak ada standar. Tapi make use it in a good way lah Okay, saya rasa itu saja kot untuk kali ini. InsyaAllah kita akan we'll probably see you back lah in the future semester tak tahu subjek apa nak ambil tu you all. So far tak ada lah, because next semester I'll be teaching professional practice for the final year dengan design for the third year, taking a studio master for third year. Mungkin when you come up later on the upper years, I'll be meeting you again kot Okay, siapa yang nak jumpa I personally boleh, macam Heba, I can have a special tutor for you if you want. I'm willing to do that for you. Ilya pun boleh siapa-siapa yang rasa nak ni, just give me a call, we fix a time. We can discuss about design. I mean your future design or future project. I'm very open. You can ask me on design also, tak mesti dan some on the subject to them. Yes. Somebody at the door. Akan lecture je. Lepas asar. Lepas asar. Okay, sorry. The first year student want to say after asar. Okay, any more? Kalau tak ada apa, we stop here and then hope to get to see your sama nanti, and then I will update on you on the what they call this, on the quiz and other things lah, like the final assignment nanti. Okay, I think I stop here. InsyaAllah kita jumpa lagi Terima kasih semua.
Thank you Haji.
Okay. InsyaAllah jumpa lagi Thank you guys. Aisyah.